So in this video, we're going to differentiate a function that has an inverse tangent in it. And this is going to be a more complicated example because we have a function composition. We have a cubing function inside the tangent inverse, inside a cosine function. And what we're going to have to do is actually construct the triangle that tangent inverse of 2x cubed is representing in order to simplify the final result. So I'm going to go ahead and rewrite the problem real quickly. So cosine of the tangent inverse of 2x cubed. So two function compositions, so we'll have to use the chain rule twice. But the first thing I want to do is look at the tangent inverse function right here. So I'm going to give it a name. I'm going to say y equals the tangent inverse of 2x cubed. In fact, the output for a inverse tangent function is an angle. So let's even call it theta. Theta equals the tangent inverse of 2x cubed. This is an angle. And then if we take the tangent of both sides, we get the tangent of that angle theta needs to equal tangent of tangent inverse will cancel, so we'll get 2x cubed. So if I want to construct this triangle, I would be constructing a right triangle that contains an angle theta that's being input into the tangent function. And we know that the tangent function by definition is opposite over adjacent. So I'm going to rewrite it with the denominator of 1 so that I can label my opposite side over my adjacent side. And then I can use the Pythagorean theorem to get the length of the hypotenuse. So it's going to be the square root of 1 squared plus 2x cubed squared is going to be 4x to the 6th. So that's from the Pythagorean theorem. So I've constructed the triangle that is represented by this angle right here. Now I can go ahead and take the derivative. So I'm going to get h prime of x equals, and I start with the outermost function, which is the cosine function. So the derivative of cosine is minus the sine. And then it's going to have all of the stuff inside the sine function that was inside the cosine function. So inside the sine function, we'll go tangent inverse of 2x cubed. And now I have to use the chain rule and take the derivative of the inside function, which is the tangent inverse function. So we're going to take the derivative of the tangent inverse, so times, and the derivative of the tangent inverse is right here. It's 1 over 1 plus the stuff that's being input into the tangent function. So 1 over 1 plus square the stuff that's inside the tangent inverse, which is the 2x cubed. And then the chain rule says now you have to multiply by the derivative of the function that's inside the tangent inverse function. So the derivative of 2x cubed is just 6x squared. And then we need to start simplifying. So this is going to equal. So this is minus the sine. And what I want to realize is that this tangent inverse that's inside the sine function is just an angle. And I gave that angle a name right here. I said, let the tangent inverse of 2x cubed be called theta. So I'm really taking the sine of theta times, start simplifying here. I'm going to get 6x squared over 1 plus 2x cubed squared is going to give me 4x to the 6th. And then what I want to recognize is that I can actually rewrite negative sine theta here using my triangle that I constructed. So what is the sine of this angle? Well, it's going to be the opposite over the hypotenuse. So I'm going to go ahead and rewrite. And I'm going to get minus the opposite, which is 2x cubed, over the hypotenuse, which is the square root of 1 plus 4x to the 6th. So I'm going to write the square root as the half power. And we're multiplying by 6x squared over, this is 1 plus 4x to the 6th. And to help us think about it, I'll write that to the first power. So now we can simplify one more time. I get negative 2 times 6 is negative 12. X cubed times x squared is x to the 5th. And this is all over. We want to notice that the base is the same in each of these expressions. So I'm going to get the base of 1 plus 4x to the 6th. And when we multiply the same base, we add the exponent. So it's 1/2 plus 1 is 3/2. So that base is getting raised to the 3/2 power. And there is the derivative of h fully simplified.